Hello everyone. Today we will going to see some practice questions from the topic redox reaction, and this is part 5. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck or have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. Okay. So these are index slides and we will going to see some practice questions from question number 30 to question number 39. Let's start with the question number 30. Which of the following statements is not correct? Options are: the oxidation number of sulfur in NH4 whole twice S2O8 is +7. The oxidation number of osmium in OSO4 is +8. The oxidation number of sulfur in H2SO5 is +6. Or the oxidation number of oxygen in KO2 is -half. So you have 10 seconds to solve this question. After that, we will see the answer. The correct answer is option A. That is, the oxidation number of sulfur in NH4 whole twice S2O8 is +7. So basically, we have to tell that which statement is not correct. So this statement in option A is not correct because if you see the oxidation number of sulfur in NH4 whole twice S2O8, the oxidation state of sulfur in this molecule will be +6. And since S2O8 2 negative, it will divide into two ions, NH4 positive plus S2O8 2 negative, right? So S2O8 2 negative has one peroxide bond, and that's why the oxidation number of sulfur in this molecule will be +6. While in the B option, it is given that osmium oxidation state will be +8, so it is right. And in the third, we have given that oxidation state of sulfur in H2SO5 is +6. This is also right since it has one peroxide bond here in this case also. And KO2, in the KO2 oxidation state of oxygen is -half. Right? So this statement is also correct. Only not correct statement is given in the option A. That is, the sulfur oxidation number in this compound is +7, which is +6 actually. Right? And thus our option A is the correct answer. Okay, let's move to the next question. Question number 31. In a reaction, 4 moles of electrons are transferred to 1 mole of HNO3. The possible product obtained due to reduction is: options are 0.5 mole of N2, 0.5 mole of N2O, 1 mole of NO2, or 1 mole of NH3. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see what is the correct answer. The answer is 0.5 mole of N2. So we have asked in the question that in a reaction, 4 moles of electron, that is 4 electron, are transferred to 1 mole of HNO3, and the possible product obtained due to the reduction is. Okay, so we have to tell the amount of possible product and the possible product which we will obtain after this reaction due to the reduction. So it is sure the reduction is happening. So if we combine the 4 electron with HNO3, the product should have a oxidation number of 1, because nitrogen has oxidation number of +5 here, and reduction is happening. So this oxidation number will be going to decrease, and plus 4 electrons is we are adding, so it will add to the 5, and the oxidation number for the product will be +1. Now in the N2O, oxidation number of nitrogen is +1. So 5 to 1, the oxidation number is changing. That means reduction is happening for sure. And thus the 0.5 mole of N2O are formed by the reduction of 1 mole of HNO3 by 4 moles of electrons. In all other, if you see in all other options, if you find out the oxidation number in these all the molecules, nitrogen oxidation number, it will not be decreasing, right? But in the case of 0.5 mole of N2O, the oxidation number is decreasing, +5 to +1, and as the question says the reduction is happening, in the reduction the oxidation number decreases. That's why we can say that in the B option, 0.5 mole of N2O are formed after the adding of 4 moles of electron into the 1 mole of HNO3 due to the reduction. Okay, and thus our B option is the correct statement. Okay, let's move to the next question. Question number 32. When the following half reactions is balanced, that is this, which of the following statement is true regarding the balanced half cell reaction? We have to find out the true or the correct statement from the options based on the given half cell, and we have to balance it. Okay, so after balancing, which statement is true? Options are: carbon is losing 2 electrons per atom. Oxidation number of carbon increases from +1 to +3. Oxidation number of nitrogen remains constant. Statement A and C both are true. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. The correct answer is option D, that is statement A and C both are true. So in the given redox reaction, which we have given in the question, CN, C triple bond N, and giving us CNO negative. Right, here also the C and N has triple bond between them. So oxidation number of nitrogen remains unchanged as -3 in both the reactant and the product. Oxidation number of carbon is increasing from +2 to +4, and hence the option A and C are the only correct response. Therefore, option D is the correct one, which says that statement A and C are both true. Right? Thus, option D is the correct answer. Okay, let's move to the next question. Question number 33. Photographic paper is developed with alkaline hydroquinone. Reaction is given for this process. Select the correct statement from the options. Options are: hydroquinone is the oxidant, Ag positive is the oxidant, Br negative is the oxidant, or Ag positive is the reductant. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is B option, that is Ag positive is the oxidant. So if you see in this reaction given for the process of development of photographic paper with the alkaline hydroquinone, so Ag positive is reduced. Ag positive gets reduced here. Hence, it is an oxidant. That's why it is reacting as an oxidant in the equation. And hydroquinone, this one, is oxidized, right? Because this hydrogen is removing and only oxygen is remaining. So hydroquinone is oxidized. Hence, it is a reductant. That's why it is a reductant. It is acting as a reductant, right? So the correct statement is option B, that is Ag positive is the oxidant. Okay. Okay. Let's move to the next question. Question number 34. For the following reaction, consider the following statements. we have given this reaction here. Twice of CrOH whole thrice plus thrice of H2O2 plus 4OH minus, giving us twice of CrO42 negative plus 8H2. First statement, there is color change from green precipitate to yellow colored solution. Second statement, oxidation number of chromium changes from +3 to +6. Third statement, oxidation number of oxygen in H2O2 changes from -2 to -1. And we have to select the correct statement among these three statements. So options are only first, both first and second, only second, both first and third. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option B, that is both first and second statement are correct. So first statement says that there is a color change from green precipitate to yellow colored solution. So CrOH whole thrice is a green precipitate, which on reaction giving us CrO42 negative here, right? So it is a yellow colored solution. So first statement is the correct statement. Second says that oxidation number of chromium changes from +3 to +6. If you find out the chromium oxidation state in here, it is in +3. If you found out in here, it is in +6. So yes, chromium is changing from +3 to +6 oxidation number. So this is also a correct statement. According to third statement, oxidation number of oxygen in H2O2 changes from -2 to -1. The oxidation number of oxygen in H2O2 changes from -1 to -2, and that's why option third or statement third is not correct, which is given. Thus, the only correct statements are first and second, and thus we have the correct answer as B option, both first and second. Okay, let's move to the next one, that is question number 35. Oxidation state of X, Y, Z are +2, +5 and -2 respectively. Formula of compound formed by these will be. We have to find out the formula formed by X, Y and Z, and we have given the oxidation state of these three. Options are X2YZ6, XY2Z6, XY5, X3YZ. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see the correct one. So the correct answer is option B, that is XY2Z6. The oxidation state of X, Y and Z are given as +2, +5 and -2 respectively. So let's see the first option, which is X2YZ6. Let's put the oxidation states given in this formula. So twice of +2 +5 +6 times -2, right? If you count this value, this is not equal to 0. So this should not be the formula, because as per the oxidation number rule, the oxidation numbers of a compound or of an element in a compound and the sum of the oxidation number of an elements in the compound should be equal to 0. The sum should be equal to 0, but is not coming out as equal to 0. So that's why this is not the correct formula. Now in the next option, we have given XY2Z6. So let's put it 2 plus 5 times 2 plus 6 times -2. If you count this is equal to 0. Right? So this may be the formula. In XY5, 2 plus 5 times 2 is not equal to 0. And in X3YZ4, 3 times 2 plus 5 plus 4 times -2 is also not equal to 0. So from this analysis, we can say that only the second option, that is XY2Z6, is the correct formula which can suit these oxidation numbers for the X, Y, and Z. Right? Perfect fit. And hence the formula of the compound will be XY2Z6 given in the option B, and the option B is the correct answer. Okay, let's move to the next question. Question number 36. I minus reduces IO3 negative to I2 and itself oxidizes to I2 in acidic medium. Final reaction is, we have given some information that there is a I minus which reduces IO3 minus to I2. This is reduction that I minus is doing, and it is itself is getting oxidized to the I2. Okay, in the acidic medium. So we have to tell the final reaction. So options are I minus plus IO3 minus plus 6H plus is giving us I2 plus 3H2O. I minus plus IO3 minus giving us I2 plus O3. 5 minus plus IO3 minus plus 6H plus giving us 3I2 plus 3H2. Or none of the above. So you have 10 seconds to solve the answer, to solve the question, and then we will see what will be the correct answer. Okay, let's see the correct one. That is option C. So this is the correct answer. 5 minus plus IO3 minus plus 6H plus giving us 3I2 plus 3H2. Right? So this is the correct final reaction in which I minus is reducing IO3 minus to I2 and itself getting oxidized to I2. Right, as we have two I atoms or one ion and another atom is present in the reactant side. So this is the final reaction as per the options given. Thus option C is the correct answer. You can also check by the oxidation numbers, right? That how if they are balancing or not. Oxidation number states the correct matching whether oxidation number change in oxidation number matching the correct statement of reduction or not. Okay, so you can check by that also. Yeah. Okay, let's move to the next question. Question number 37. Thiosulfate reacts differently with iodine and bromine in the reactions given below. So thiosulfate reacting with iodine giving us S4O6 2 negative plus 2I minus, and thiosulfate reacting with bromine plus 5H2 in a aqueous solution giving us 2SO4 2 negative plus 4Br negative ion plus 10H positive ion. Okay, so same is the reactant, that is thiosulfate, right? But it is behaving differently, reacting differently with iodine and bromine. So we have to tell that which of the following statements from the option justify the above dual behavior of thiosulfate, which is just showing with iodine and bromine. Options are bromine is a stronger oxidant than iodine. Bromine is a weaker oxidant than iodine. Thiosulfate undergoes oxidation by bromine and reduction by iodine in these reactions. Or bromine undergoes oxidation and iodine undergoes reduction in these reactions. So what is the statement which justifies these two different behavior of thiosulfate with iodine and bromine respectively? So you have 10 seconds to solve this question. After that, we will see the answer. Okay. So let's see. The correct answer is option A, that is bromine is a stronger oxidant than iodine. So if you see this reaction with the iodine of thiosulfate, 2S2O3 2 negative plus I2, in which S is having plus 2 oxidation number, O is having minus 2, I2 is having 0 bit because it is an elementary form, giving us S4O6 in which sulfur is having 2.5 oxidation number plus 2I negative in which I is having minus 1 oxidation number, right? And in the second reaction for the bromine with the thiosulfate, we have sulfur in plus 2, oxygen minus 2, bromine in 0, plus 5H2, giving us 2 molecule of SO4 2 negative, sulfur in plus 6, oxygen in minus 2, plus 4Br negative, bromine in minus 1, plus 10H positive. So bromine being stronger oxidizing agent than iodine oxidizes sulfur of S2O3 2 negative to SO4 2 negative, whereas iodine oxidizes it only into S4O6 2 negative ion. Okay, so bromine being stronger oxidizing agent, it is oxidizing the sulfur of S2O3 negative to the SO4 2 negative. You can see that sulfur from +2 is increasing to +6. Difference is 4 plus 4, right? Whether if you see this in iodine reaction with the thiosulfate, sulfur is in +2. So iodine is oxidizing it to 2.5. Only 0.5, increase of the oxidation number. So bromine being stronger oxidizing agent, oxidizing S2O3 to SO4 2 negative, that is oxidizing sulfur, and whereas iodine oxidizes it only to the S4O6 2 negative, and this is the difference between these two reactions. That's why the reaction is different, the behavior is different with the bromine and with the iodine of thiosulfate, right? And thus the correct answer is option A, that is bromine is a stronger oxidant than iodine. Okay. Let's move to the next one, that is question number 38. Which has maximum number of equivalent per mole of oxidant? Options are zinc plus VO2 positive will giving us zinc 2 positive plus V3 positive. Ag plus NO3 negative giving us Ag positive plus NO2. Magnesium plus VO4 3 negative giving us Mg2 positive plus V2 positive. Or I negative plus IO3 negative giving us I3 negative. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the correct answer. So the correct answer is option D, that is I negative plus IO3 negative giving us I3 negative. So we have to find out the maximum number of equivalent per mole of oxidant from the given reactions. So in the A reaction, VO2 plus giving us V3 plus, right? So the oxidation state of V here is +4 and V in the product oxidation number is +3. So the change in oxidation number is 1 unit and the number of equivalent will be 1. In the B option, NO3 minus giving us NO2. The nitrogen oxidation number is +5. In the product, nitrogen oxidation number is +4. So change in the oxidation number is 1 unit and the number of equivalent will be 1. In the C option, we have VO4 3 negative, in which V has a oxidation number of +5. And in the product, V has oxidation number of +2. The change in oxidation number is 3 units and number of equivalent will be 3. And D option, IO3 negative, I is in +5. In the product, I3 negative, in which I is in -1 by 3 units. So change in oxidation number will be 5 minus of 5 minus of 1 by 3. So minus will become plus. So 5 plus 1 by 3 will be 16 by 3 units. So number of equivalent will be 16 by 3. So the maximum number of equivalents per mole of oxidant will be this much. Because if you solve this, it will be 5 point something. 3 times 5 will be 15, So this will be 5 point something, which is highest, which is maximum number of equivalent per mole of the oxidant among the 4 options given, right? And that's why our option D, that is I minus plus IO3 minus giving us I3 minus, is the correct answer. Okay, let's move to the next one, that is question number 39. For the reaction between MnO4 negative and C2O42 negative in a basic solution, the unbalanced equation is MnO4 negative plus C2O42 negative giving us MnO2 plus CO2. In a balanced equation, the number of OH minus, so we have asked the number of OH minus ions present in a balanced equation and we have given the unbalanced equation here. So we have to firstly balance it. So options are 0, 8 on the right, 4 on the left, 2 on the left. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. The correct answer is option B, that is 8 on the right. So this one is the balanced equation for the unbalanced equation given in the question. 2MnO4 negative plus 3C2O4 negative plus 4H2 giving us 2MnO2 plus 6CO2 plus 8OH minus. Okay. So therefore, the number of OH minus ions is 8 on the right side in the balanced equation. Right. And thus, B option is the correct one, that is 8 on the right. Because we have asked the number of OH minus present in the balanced equation, which is 8 number of OH minus on the right side of equation. Thus option B is the correct answer.